one of the reasons I invited Joseph French from uh, Xoran Technology. Xoran has uh, many CT scanners and ENT offices. I know Zoran has been working on a new platforms. Tell us more, Joe, in the next 10-15 minutes.
Yeah, so I'll try to go very quickly here. I did prepare some slides, but I kind of framed it here in a little bit of kind of introduction to Xoran and kind of the the current products that we have and some of the research efforts that we have going on, which maybe you'll be more interested in. So I'll try to fly through the stuff here if we can get you out on time. So Xoran was, founded in 2001. We've been doing this for 20 years now. And one of the great benefits of the Xoran team is we do all of our engineering and research in-house. And we have a large data set. So we have about 5 million patients that we've assisted in serving. So we have a lot of information to be able to lean on to be able to continue to develop and improve our imaging systems here. So a little bit about our pipeline. We're definitely dedicated to improving imaging, and over time we have, like as you stated, a large amount of different types of CT scanners, even more recently doing things in portable, and then of course most recently release of our MiniCat IQ Plus product. On that side, we've been able to drive down dose and increase resolution with maintaining a small footprint that gives us of course, the ability to do point of care placements of our CT scanners, shortening the time frame that it takes for a patient to be able to be seen and actually begin treatment. Moving forward, so it's MiniCat 2020, just kind of sinus sample. I'm sure all of you are very familiar with these types of images. And then, of course, our latest MiniCat IQ Plus. The great thing about this is now we've been able to optimize the images well enough that the Hounsfield units are extremely stable. The image is extremely flat, where typically you have copying and cone issues with images. That allows us to do more detailed image processing and a little bit more analytics of the data, which I'll show you a little bit later, which help with diagnostics and help with being able to do the types of things and types of research that you're after. One of those places, of course, is in the ear. We've heard a lot about the ear, or a little bit about the ear today. So we have very high resolution images now that we can get down to 70 microns and still maintain a low signal to noise ratio. This high resolution, of course, allow for easy interpretation of those scans. If I'm going too fast, just let me know. I'm just trying to make sure we stay on time. Then, of course, we have portable imaging solutions as well. And we saw extremely small footprint, easy to use in the OR or the ICU. Mainly, Xoran has been focused on the head, but most recently, within the last year or so, released a portable CT that can scan the entire body. Those devices are being used, of course, for inner ear and cochlear placements and evaluation. And it really helped to pioneer for our research group some new procedures to be able to optimize the cochlear placement and actually be able to do an immediate follow-up scan inside the OR to be able to get the measurements for the placement of the electrodes. So either they need to be adjusted in in real time, or start making measurements so that you can work on getting the calibration ready for the next visit without having to do another scan or another follow-up at a patient. In addition, we've been able to do soft tissue imaging through these portable scanners as well. So a lot of work here with being able to do DBS surgeries, and which is of course delivered through the sinus passages or by planning stents for diagnosing stroke and things of that nature in many different areas. And then on to the fun stuff, right? So our research side of things that we're still continuing to do. One of the great things is Xoran continues to partner with their research partners and, of course, our customers. We listen, we try to update and provide improved features. So the next set of slides are not released, so but it's very much on the research side of things. Is some of the things as we go through and try to improve imaging is the patient factors, right? So there's only so much we can do as far as creating an improved scanner with improved resolution if the patient's going to move or doesn't have the ability to sit still. So we've been able to develop a algorithm that we're hoping to commercialize within the next year or two that allows us to correct image motion. The great thing about this is we don't have to track any part of the patient during the scan. We can take a scan that was done 2 years ago and apply this new algorithm with the use of some AI learning and correct with a very high level of accuracy that motion. So this helps to service patients that couldn't normally be served by this type of technology. Next is in the ear. We have this is fairly recent, is we've had some focus on the ear canal. So, and this is what you're seeing here is a segmentation of the ear canal, and then of course creating a negative image that we can then export as a 3D model, so be able to use for in place of having to do a inner ear mold. So with a very, very high level of accuracy of the measurements of the inner ear, all the way up to the tympanic membrane and umbo. So this, of course, we've used to place hearing aids or deliver, accurately through image guidance systems and things of that nature. So we're very excited about this. Next is kind of the possibilities for multi-density visualization of objects this is not new within CT, right? But now being able to do this with cone beam and be able to get the dose down, and now being able to make it extremely portable. So one of the things that we've worked on with one of our partners here, and we're hoping will be up soon, is the ability to do this on a very portable method, maybe on a van or other methods, to be able to go to different underserved communities to be able to do lung screenings right in place with extremely low dose CT, easy visualization, and moving forward. But the other place that may be more interesting to you is the multi-density visualization of the skull and skull base and imaging. So now that we've kind of broken the barrier of soft tissue and bone window visualization and flatness of the image and Hounsfield accuracy, we're able to take that multidimensional image and use it for identifying specific areas of interest and helping planning or guidance on how to reach specific areas inside the head or the brain. Yeah. So I know I went through that very, very quickly, but if you have any questions or want me to go back through or see something more, I'm happy to do that.